Hello, I'm Dr. Jeff Grover. I'm the Chief Research Scientist here at Grover Group Incorporated, and welcome to our series. And this series is on our capabilities in Python and other statistical software. Today we're going to highlight how we go to Medicare.gov, download CSV data, and then take that CSV data, sift it through Python, code in Python to generate Bayesian belief network posterior probabilities. And so we want to highlight this capability. So this is the site we go to, data.medicare.gov, and this is the data we're going to use, hospital compare data. This data comes in a CSV format. So what we've done, we've downloaded this CSV onto our desktop. This is the CSV for evaluation. So this is the data that's contained in that CSV file, and this is what we're looking for. We're interested in the complications and death for all the hospitals. So this is our Python code, and what this does is calculates the posterior probabilities, and this is our protocol. So what we've done, we've created a dictionary, and in that dictionary we've included the data set that we just downloaded. This is the same name from the zip file that the data comes in, and then we've created the data dictionary of these fields that are contained in the data. And what we're looking at is going to be the state, the measurement name, and how it compares to a national evaluation. So this is our data dictionary, and this is how we read these results. And then these are the snippets that we're not interested in evaluating. So we take those out of each of the rows. Not available, number of cases are too small, no difference in the national value, worse or better than the national value. So this data set contains national values, and we're not interested in that. We're really interested in the fields that come with compared to national. And so we're doing a quick cross tab, and we're going to look at state, the measurement name, and how that's compared to the national. We're going to write this into Excel, and this is where it's going to go. And we're just going to name it tab 1. And this is where we will be able to see our results. And so next, we'll run. I'll go and fetch this complications and death. So I'm running it within Python desktop. So it calculates the posterior probabilities. And so it's going through its calculation process. These are the results. And then next, I'll take you to the Excel data files, posteriors, complications and death, and so these are the posterior probabilities. Better than the national rate, no different, and worse than the national rate. Then we'll just make these into percentages. And so the way this is read is that the probability of the state of Alaska, we'll just go with this posterior, the probability of the state of Alaska being worse than the national rate, given this is the state of Alaska and given its 30-day mortality rate for pneumonia, is 8.33%. So these are the posterior probabilities, and they are evaluated for each of the states. So, for example, Arizona, the posterior probability of the death rate for CABG is 100%, and that is no different from the national rate. So I guess, I'm not sure what CABG is, but it must not be a very good thing there. So this is how we read and calculate the posterior probabilities and go through each one of the states. So you probably wouldn't want to go to